Okay, you guys, I wanted to go over 215 and sort of summarize what the whole lesson is talking about. So when we're doing 215, the first thing is what we're doing is we're comparing quantities, right? So we're just asking which things are great, like which is greater, which side is greater. And so we can tell by looking here. Sometimes it's really easy to do this because you can tell by looking. So over here on the left side, we can see that the value of the board was 0. They put 3 negatives on the top, so that is 0, and then it's on the plus side, so 0 plus -3, which equals -3, right? Any number plus 0 is always equal to -3. And then over here, the value on the board was 0, and then they put these two positives on the negative side. So this is going to be equal to 0 minus, because it's on the subtraction side, +2, and 0 minus 2. So if you start at 0 and you go down 2, you are going to end up at equals -2. And so the question is just which one is bigger. Some students think this one's bigger. The one on the left is bigger because there's more tiles. And some of them think it's bigger because they're on the top. But in reality, this one is actually higher. Like if I was to draw a number line out and actually think about where these numbers are, let's say I go 2, 1, 0, -1, -2, -3. When I look at these numbers and I want to know which one's the higher number, I can see that -2 is a higher number. It is directly above -3. It's just as much higher than -3 as 2 is higher than 1, right? We know that 2 is higher. So what we're doing, like we're starting out with pretty basic comparing numbers, but we're going to start talking about how we do that if we need to simplify. One thing that might settle some confusion here, though, is that one thing that I wanted to show you guys is that if we remember this move called keep, change, change, keep, change, change. Sometimes when these things are hard to tell, if I do keep, change, change, then what that does is it makes it so I can convert my equation so that I can think about it in a way that makes more sense. Some students may get confused by 0, whether 0 plus -3 is bigger than 0 minus -2, and that is because subtracting negatives is like really conceptually confusing. But if I remember that I can, if I remember keep, change, change, keep, change, change says that is sort of what happens with the Up house, right? The house in the movie Up, it will go up if weights are negative. If you take away 2 weights, that's going to make the house go up a little bit. But the other thing that makes the house go up a little bit would be adding 2 positives, so adding 2 balloons. So if I remember that 0 minus -2 is the same as 0 plus +2, then that's where I keep, change, change. I keep this, and then change the operation, change the operation, and change the sign. And so, right, they change into these. So I do keep, change, change, and then what that will do is that will make these -1 up here on the top. And so what it does is when you cross the line and change the sign, right, what you had down here turns into that up there, and so these are equal. And anyway, it might seem easier to see now that -3, sometimes it's easier to conceptualize -3 is further negative than -2. So sometimes if you're having trouble, you can use keep, change, change to help you. Okay, so the next thing that I wanted to talk about was the next problem in 215. And we're going to sort of talk about what they're doing. The first thing, this is sort of what we did on our quiz, is we're just going to write out what are these so it can be harder to tell which one's larger when you have all of these complicated tiles. Complicated tiles represent a complicated expression. So if I was actually going to show the expressions that are made by both of these, I would write that over here on the left is x, and then I see that there's two positives, so plus 2, and then there's two negatives, so plus negative 2. That's all on the top, and then on the bottom there's minus, and then there's these three positives down here on the bottom, so minus 3. And then over here on the right, I see the x is on the top, so I'm going to write positive x. And then I see that we are adding 2, but then I see that we are also adding negative 3, and then we're subtracting negative 2. So I'm going to put my parentheses in so I don't get confused. Put them all in all the way across here. And so when I look at a big complicated expression like this, the question is, which one is bigger? And that can be harder to tell. So what we do is we use our simplifying steps to help us. So when I look at this, let me see, what are my simplifying steps that I have learned about already? I already know that I can cancel zero pairs. So I see a zero pair on the left right there, and another zero pair right there. And then on the right, let's see, I see a zero pair here. I see a zero pair here, and then I see another zero pair right there. So when I'm considering those, like now I can look at what's left over, and I see that what I have left over, my simplified version, is I've simplified it a little bit, and now I have x minus 3, and I have x minus negative 1 as my answers. You can see I've written those down here at the bottom already. So that's simplified a little bit. There is a little bit more simplifying that I can do, however. So one thing that I can do is, and this is what we're supposed to be learning, is something called removing a balanced set. So we've talked about what balanced sets are a little bit. The way that a balanced set works. One thing I forgot to say, I'm sorry, before I go to balanced sets, one thing that I can do when I simplify, when I go from these expressions, one last thing I can do is I can do keep, change, change. I'm going to do keep, change, change here. I guess I could do it on both sides. But this is going to show when we get into like subtracting negatives, that gets really confusing for some students. But if I do keep, change, change, this can move up to the top and become, I can fill it in and it will become a positive number. So I just wanted to show that that is reflected down here, that x, this is still x minus 3, and this is still x plus 1. Now, I should be able to tell now what value, which one of these is greater. This is now easier for me to tell. Some students are going to get confused because they're not exactly sure what the value of x is, but I can tell that because I know that x is going to be the same in both of these, that because they're being compared, whatever x is over here, x is going to be the same over here. So no matter what x is, the question is it bigger if you add 1 to it or if you take 3 away from it? And it doesn't matter what it is, it's always going to be bigger if you add 1 to it. So, so now I definitely know that x, that I can tell that x plus 1 is larger. But if you're still confused by that, we can do what's called removing a balanced set. And removing a balanced set means that you, it sort of works like I think about like little kids playing on like a teeter-totter in the park. And so if two kids weigh the exact same amount in the park, if you have two equations that are balanced, this works. But it also works if you have two equations that are imbalanced. If I have two equations that are imbalanced, where I have kids, where I have like a bigger kid and a smaller kid. So let's say I have like my 7-year-old is on this side, and my 3-year-old is on this side. My 4-year-old is on this side. My 7-year-old just weighs more, and so my 7-year-old is going to like pull down further than my 3-year-old is. It doesn't matter which one of these it is. The relationship is going to be the relationship in both of these cases is going to be the same, and is going to be consistent like this, unless you do something to change one side, and then you're not comparing the same things anymore. But if I wanted to add something, let's say another kid came along and jumped on this side, what's gonna happen to this side is that the side where the kid hops on is gonna start going down. And the only way to change that is to either have this kid jump off or have another kid of the same size come jump on the other side. So that's going to balance it out. Another thing that you could think of is what if you put a backpack on this kid? What if this kid had a backpack? That's going to make him go down. But then putting an equal sized backpack on this kid is going to make it balance back out. But what if this kid takes their backpack off, now they're lighter again, the kid over here on the left is going to be heavier unless they take their backpack off. So what this is about adding equal things to both sides. The balance is going to change unless you keep adding or subtracting the same thing to both sides. So you can keep the relationship between the two sides balanced if you are always making sure that if ever you take away something from one side, you don't take it away from the other. And it still works for imbalanced. Like if let's say the backpack goes on my younger kid here, she's going to start pulling down, but if we put the same size backpack back on here, then the relationship will stay where my 7-year-old weighs as much more than my 4-year-old. It's going to be the same relationship. So that's sort of how balance sets work. So what I can do when I'm looking at this to simplify it is I can start to think, well, what is something that is the exact same on both of these? Adding 1 is not the same as subtracting 3. Adding 1 isn't even the same as subtracting 1, but there is one thing that's happening in both of them that's the same, and that's these x's. So I'm actually going to take these x's, and I'm going to just erase them. I'm going to delete them. They are going to go away, just like the kids on the teeter-totter. And so once those are gone, what I'm left with is the plus 1 and the minus 3. What that looks like mathematically, if I compare it to this, is I say, well, if I have x plus 1 and I subtract x, then what I'm just left with is just plus 1. And if I have x minus 3 and I subtract x, what I'm going to be left with is just minus 3. So, and that's okay. But now it's really easy to tell which one is bigger. If you weren't sure about x before, then if there's no x, now you definitely get to ask, well, what's bigger? 0 plus 1 or 0 minus 3, right? Which one's bigger? It's pretty easy. We definitely know that 1 is bigger. So this is the last simplifying move. The last simplifying move is called removing a balance set. And removing a balanced set is taking away an equal, also known as balanced, amount from both sides of an equation or two compared expressions. Okay, so I mean, just that's how that works. So we're going to be practicing this more in class, and we'll be practicing this during the rest of 215.